Today we're talking about adding and subtracting numbers in scientific notation. Our objective is I can add, subtract, multiply, and divide numbers in scientific notation. We've already done the multiply and divide, so today we're talking about adding and subtracting. And the steps are different than when you multiply and divide. So I want to start off with a little exercise here, just kind of a common sense exercise to help get you thinking about what it means to add and subtract numbers in scientific notation before we even really get into the steps here. So I want to just go through kind of a simple idea here, or a simple problem, which is 1 million. And in scientific notation, 1 million would be 1 times 10 to the 6th. So let's write it in scientific notation. So 1 million plus 1 million. So 1 times 10 to the 6th. So without really thinking about that operation there, just mental math. What is 1 million plus 1 million? Well, 1 million plus 1 million would be 2 million, right? And in scientific notation, we'd write that as 2 times 10 to the 6th. So this sort of unlocks the steps for us here. You can see what happened is we added these two coefficients together. 1 plus 1 gave us 2. But the exponent didn't change. It was still in the millions. We're not going to add those exponents together because that would give us an outrageous number compared to what we're looking for, which is something just in the millions. It'd be 10 to the 12th, which is a lot larger. So just that exercise kind of helps us see a little bit about what we're going to be getting into today. The next one I want to show you here is going to help us see why there's going to be an important step here that we start off with here in step number 1. So let's say we have something that's very similar to this problem, 1 times 10 to the 6th, 1 million plus 100,000. 100,000 is 1 times 10 to the 5th. 10 to the 5th is 100,000, so 1 times 100,000 would be 100,000. So 1 times 10 to the 6th and 1 times 10 to the 5th, what is, just thinking about, again, just mental math, what is a million plus 100,000? So a million plus 100,000 would be 1,100,000. Right? So this time it's not going to work to just add the numbers, the coefficients together, and we can't keep the exponent the same because it's not the same between these two to begin with. So we're going to run into a little bit of a problem here of how do we do that? So we're going to get into that now as we work our way through these steps. So evaluate each expression, express the result in scientific notation. We got one addition problem, one subtraction problem. Let's take a look at these two. The first step today, which kind of goes back to what we talked about here just a second ago, is to make sure that the exponents are the same. We're not going to add and subtract any numbers in scientific notation until the exponents match up. It's kind of like when you're doing fractions and you have to add and subtract fractions. You have to make sure that the denominators are the same first. We have to make sure that those agree before, it's kind of like, it's a place value thing. Before we're allowed to add those coefficients together, we have to make sure those exponents are the same. So in A, they are the same already. 10 to the 8th is 100 million. So these are both in the 100 millions. So because they're both in the 100 millions, we can just add the coefficients together. So we don't really need to do anything for step number 1 on this one. For step number 2, we got 3.1 plus 1.1. And we may be doing some calculator work with these decimal numbers today, but for this one, we can probably figure this out here. 3 plus 1 is 4, and 0.1 and 0.1 is 0.2, so 4.2 altogether. You could also line this up and do 3.1 plus 1.1 and get it that way. 2.4, so 4.2. So we're going to rewrite our new coefficient as 4.2. And then if the exponent was the same in our original problem, this is basically 300 million times 100 million. It's going to be 400 million. So it's still in the 100 millions. So the exponent stays the same in the answer. Step number 4 is to adjust our answer if it's not in scientific notation. So the key is to look at this number and make sure the decimal's in the right spot. Do we have a number between 1 and 10? And if we do, we're good to go. So there's nothing that needs to be changed on that one. So that's about as easy as it gets with adding and subtracting numbers in scientific notation. Just for adding, if the exponents are already the same, just add the coefficients, and then you keep the exponent the same in the answer. So that's pretty basic, but we will get into some more complicated or some tougher ones here. So let's do B here. First of all, we need to make sure the exponents are the same, and here they are not. We have 10 to the 3rd power and 10 to the 2nd power. So we have the choice to either make the two 10 to the 2nd power or 10 to the 3rd power. I'm going to tell you right now, most of the time, not every time, but most of the time, it's easier to go ahead and make the one that is less match the one that is more. So I'm going to rewrite this now. Instead of 10 to the second power, I'm going to make it 10 to the third power. But I can't just change this exponent without making up the difference by moving the decimal here, because then I'll have changed the value of the number, and I don't want to do that. So if I go up here with this, going from basically this is 10 to the second is 100 to 10 to the third would be 1,000, I have to make up the difference by moving the decimal to keep the value of the number the same. If I went up here, I got to go back with my decimal. So this is 0.51 now times 10 to the third power. This number isn't technically in scientific notation anymore, but it's going to allow me to do this subtraction now that my exponents are the same. So step number 2 with subtraction is to subtract the two coefficients. So we're going to line this up, 5.3 minus 0.51. Go ahead and put a 0 here to make those match. I want to borrow from the 3 here, that's 2. 10 minus 1 is 9. 2 minus 5 can't be done, so I borrow from the 5. 12 minus 5 is 7. Bring down my decimal point. So 4.79 is my new coefficient, 4.79. And then the exponents, I made them the same there. I worked to get them both to be 10 to the third, so this would be 10 to the third. Is my answer in scientific notation? It is. We're going to run into some today that do not end up in scientific notation, so we'll talk more about step number 4 here as we move along. But I wanted you to see one there where we had to make some adjustments by moving the decimal point and changing the exponent before we could add or subtract. So you want to watch out for those today as we work through these problems. Let's take a look at the first together problem here. So go ahead and write this down. This is 4.7 times 10 to the third. And on this first one, we're going to be adding 3.8 times, put this in parentheses, 3.8 times 10 to the third. Sometimes you'll see numbers in scientific notation in parentheses, and sometimes you won't. Sometimes it's just say, hey, all this stuff belongs together. It's one number. So we have adding here. We check to make sure the exponents are the same. They are. So we can go ahead and add our two coefficients, 4.7 plus 3.8. Let's see, 8 plus 7 is 15. Decimal point, 1 plus 4 plus 3 is 8. So we got 8.5. 8.5 is our new coefficient. And in adding and subtracting, the exponent stays the same, 10 to the third. 10 to the third is 1,000, so this is about 4,000 plus about 3,000, ends up being, because of what we have left over there, a little over 8,000, right? So we're taking a look here at number 2 now. That one is pretty basic, pretty straightforward. Let's see if anything changes here on this one. Number 2 is 7.9 times 10 to the negative fifth plus 8.8 times 10 to the negative fifth. All right, well, looks like again we're in store for a pretty easy problem here because the exponents are the same. But that's not the only difficulty we'll run into today. As we get started with this one, even though the exponents are the same, we can go ahead and add, so that's nice, 7.9 plus 8.8. We're going to run into something when we do this addition here. 9 plus 8 is 17, and 1 plus 7 plus 8 is 16. So bring down our decimal point. We get 16.7. So you might see the difficulty we're into here in just a minute, times 10 to the negative fifth. So this is the step number 4 that we were referencing just a little bit ago, is that we have to adjust our answer if it's not in scientific notation. Remember, our coefficient has to be a number between 1 and 10. The rule is basically that you're going to have the decimal after the first digit, and this is after the second digit, so 16.7. This doesn't qualify as scientific notation. So we're going to have to move the decimal point. We're going to go from 16.7 to 1.67. But again, we can't just change this number without making up the difference somehow with the exponent. So here's the thought process you need to go through when you move the decimal point. If you move the decimal point to make this, in this case, it went from 16 to 1.6, or 16 to 1 as your whole number, you need to be thinking about, did I go up or down from what I used to be? So if we increase this, in this case we're decreasing though, so if we decrease this from 16 to 1, well, that means we have to increase the exponent. So you do the opposite to make sure it balances out. We went up from 16 down to 1, so we're going to go, because we went down here, we have to go up with the exponent. So we have to go one more, because we only move this one space. We go up one more from negative 5. What's one more than negative 5? Negative 4, right? So 16.7 times 10 to the fifth is the same as 1.67 times 10 to the negative fourth. So just got to keep track of how you move the decimal and do the opposite for how you change the exponent to make sure it balances out and it has the same value. All right, let's do some subtraction here. Number 3 is 5.79 times 10 to the negative 7th. And then we're going to be subtracting 4.2 times 10 to the negative 5th. This one is going to be pretty interesting here. This is really going to start showing you some of the intricacies we get into when we add and subtract numbers in scientific notation. The first thing is that we have to make the exponents the same, right? So we're looking at these and we have exponents of negative 5 and negative 7. So because they don't match, we have to move one of the decimals to make it match and change the exponent. So we're trying to match the one that is greater. That's usually going to be the better deal here. So negative 5 is greater than negative 7. You think about positive and negative numbers. So I'm going to change this to negative 5. But when I do that, I went from negative 7 up to negative 5. I went up 2. So I have to make this less by 2. So I've got to go down 2 spaces. So it's going to be 0.0579 times 10 to the negative 5th. Now my exponents are the same. And now it's time to subtract. I'm going to use my calculator for this because this is where things can get a little bit tricky. So if you don't have your calculator, go ahead and get that. We're going to be subtracting the coefficients now. 0.0579 minus 4.2. So 0.0579 minus 4.2. And before we get equals here, I want you to notice something. The number we're subtracting is greater than the number that we started off with. So if we're subtracting more than we have, we will end up with a negative number, negative 4.1421. So we're going to write that down as our new coefficient, negative 4.1421 times 10 to the, and the exponent will stay the same, negative 5. Now all along I've told you guys that this number needs to be between 1 and 10 in order to be scientific notation, and because this is negative you might think that that's not between 1 and 10. What I should have been saying probably is that then the number really needs to be between the absolute value. The absolute value needs to be between 1 and 10. So it's okay for this to be a negative as long as that decimal still comes after that first digit. We just end up with a negative answer. So that will be your final answer there with that negative. So you will get some numbers in scientific notation that are negative, and this one even has a negative exponent. So it's very close to 0, but on the negative side of things. All right, let's do one more subtraction problem here, and then we'll be done with this. We'll do some more practice in class. 1.1 times 10 to the 8th. And that's the first one. They're going to be subtracting 9.8 times 10. Let's do 9.81. 9.81 times 10 to the 7th power. All right, once again, our exponents are not the same, so we're going to need to make this one match the one that is greater there. So we'll make this a 7. We went up to 8, so that means we will go back 1 with that. So 0.981 times 10 to the 8th. And now I'm ready to subtract 1.1. For time's sake here, since we're getting a little low on time, I'll use my calculator for this. 1.1 minus 0.981 leaves me with 0.119. Again, the exponent will stay the same, times 10 to the 8th. But this is not scientific notation. I don't have an absolute value that is between 1 and 10. So I'm going to have to move this decimal over 1 space there, making it 1.19. Now I went from making it point something to 1 point something. I went up in value here. So that means I have to go down in value with my exponent. From 8 down 1, because I only moved 1 space, down to 7. So 1.19 times 10 to the 7th. So we'll do a few more problems like this. Things can get tricky with adding and subtracting. You got to make sure those exponents are the same, and then you got to make sure your final answer's in scientific notation as well. So we'll do more in class.